In the world of innovation, ideas are born in the ethereal realm of imagination. Every line drawn, every angle is perfected, serves a greater purpose. It's not just about aesthetics, it's also about functionality, efficiency, and manufacturability. But the design is just the beginning. From here, these ideas begin their transformation. From the virtual model to the tangible world of manufacturing is the journey from design to manufacture. Hi, my name is Rebecca, a project manager at WayKen Rapid Manufacturing. Welcome back to another episode of our series, MachinEpic. As a custom part manufacturer, we process a very large number of different types of parts on a daily basis. And at the production site, we need to ensure both high quality and efficiency, which means we have to analyze the machining options before production. The customer's focus in the design will be on the functional purpose of the product, as well as the cosmetic effect, sometimes ignoring the fact that some features are not easy to be machined. And this is where the gap is. But DFM solves it by analyzing the design from a manufacturing perspective, choosing the right material and the best machining solution will help you bring the product to the market quicker and cheaper. This is a housing for a military camera case that we once machined. Since this product will be carried by soldiers all the time, lightweight is very important for its application. So magnesium alloy is therefore the best option. Designer also aim to reduce the weight by removing the materials from the walls. So as you can see, these are all thin walls. Now let's take a closer look at the inner structure of the parts. As you can see here, we have some undercuts, and also here, these are undercuts as well, and also here. These undercuts are a hassle for machining because no matter how the part is rotated or how the cutting tool is rotated, the cutting tools just cannot reach all the surfaces in here. We discussed with the engineers and the designers to change the design by removing the undercuts here, but it seems that it's not possible because there will be an optical module later to come into this section here. So how can we remove the material in these areas? Well, EDM is the solution. EDM, Electrical Discharge Machining, is also called spark machining. It's a great way to machine internal features that a cutting tool cannot reach. So in this process, the electrode is shaped to mirror the desired feature. And this discharge creates an electrical spark that removes the material from the workpiece. A T-shaped cutter can be used to realize the structure or undercuts in between these two knobs. But because we want to save time or the cost, we use EDM to make these structure because we can make these all in one setup. Besides metal parts, we also make plastic parts. So here I'm holding a transparent housing. In most cases, people produce these parts by injection molding. But for prototypes, because the quantity is too small, we cannot invest in tooling. So we have to make it by CNC machining. Unlike injection molding, this structure cannot be realized due to its deep structure. Of course, we can choose 5 axes, but because it's too deep, still it's not doable. So in these cases, we choose to use a split machining. So we split these parts into up to 9 pieces. We use this mold master pattern to make this mold. Some people call it vacuum casting, some people call it silicon molding, but whatever you call it, it's the same process and the final product cast out of this mold is very beautiful. After CNC machining the pieces, we start to bond the pieces together by gluing. The dimensional accuracy largely depends on the processing experience of our hand craftsmen. With more than 10 years of experience, they have highly skilled hand craftsmen to do the work, so your parts will always look beautiful. You may worry about the rigidity or appearance of the parts, but rest assured, in most cases, it is strong enough for the proper functioning, especially for prototypes. And the joint marks won't be very obvious in most cases. But of course, we understand your concerns, so before quotation or before production, we always discuss with our customers about the splitting machining proposals. That is why DFM is so important. You need to discuss with your vendors, your suppliers, to see whether it is feasible to make the parts or to seek solutions to drive down the costs. Splitting machining is a great way to drive down the costs in most cases. Another aspect of DFM is fillet. In order to keep your CNC project on budget, you should increase the size of all fillets or add undercuts to sharp corners. Why? Because most CNC cutting tools have a cylindrical shape with a flat or spherical end. Let's imagine you want the internal corners of your parts to have sharp corners. You simply can't manufacture that. The internal vertical corners of the CNC machine parts will always have a radius, no matter how small of a cutting tool you use. Of course, you can make the sharp corners by EDM, but the cost will be high and the service quality will usually drop. This is an aluminum holder that we're making. The making piece that comes into the cavity here has 4 90 degrees sharp corners. So how do we make sure the assembly between these two parts? Well, you can make the sharp corners by EDM, but as I said, the process is usually expensive and also time-consuming. Or we can add 4 rounded corners as shown here. We mill most of the cavity with a larger tool and then replace with a smaller milling tool to machine the added corners. Based on my experience manufacturing similar parts, this is very common and I have to say it is smart. So if you need internal edges with sharp corners, instead of reducing the internal edges radius, use a shape with undercuts like this. Last but not least, tolerance. Defining tight tolerances increases the cost of machining a feature, so it should be only done when absolutely necessary. If a specific tolerance is not defined in the technical drawing, the parts are machined using the standard tolerance. Higher tolerances usually ends up with high machining costs. Designers should also consider cost effectiveness when calling out high tolerances, instead of always thinking about high standard. Also, remember to specify critical dimensions and provide tolerance for different priorities. For example, let's take a look at this 2D drawing in here. This 2D drawing is very clear about the critical dimensions and how we should control the tolerances for different dimensions. Do not use the same tolerances for all dimensions without considering the scrape rate. When the manufacturer receives a 2D drawing like this and we are required to control all the dimensions with 0.05 mm, we'll feel very confused. We understand that the hole diameter, the locations of the holes are important, but the outer length and width do not affect its function. So it is not necessary to apply 0.05 mm for the outer shape of the part. GD&T includes features such as flatness, straightness, circularity, and true position. It usually means higher standard, so unless necessary, do not add them on the 2D drawings. Otherwise, it will be also time and money consuming. Adopting DFM principles in CNC machining isn't just about reducing costs. It's also about thinking ahead, innovating and crafting designs that are truly optimized for the future of manufacturing. By working together closely, designers and manufacturers ensure that the final product is not only manufacturable, but also aligns with the project's quality, cost, and time requirements. In conclusion, I would like to re-emphasize the above common CNC machining points. Number 1. Use as large fillets as possible. Number 2. Reduce the number of undercuts that must be EDM'd or consider disassembly and gluing the parts together. Number 3. Do not just pursue high tolerances. Think about the actual needs of the product and use affordable tolerances. Only specify tight tolerance when it is a must. If you find this video insightful or interesting, remember to like, share, or subscribe for more content. Drop your questions or experiences with DFM in the comments below. Until next time, keep innovating.